It's the weekend. I've got my dark and stormy here ready to drink. And it's time to make something and answer questions from the recent video when I said, ask me questions, ask me anything. So here's what we're going to be doing. I'm going to be making a lamp. It's a similar lamp to one I've made before, but you know what? This one's going to be different. And I'm going to be answering questions while I make the lamp. So the circuitry is going to be very, very simple. Mains come in, because it is a mains voltage lamp, and I'm going to be using this slim test tube. And I'm going to be using a resistive limiter. Very simple. Lots of resistors because it spreads the dissipation and also means that they're not stressed voltage-wise. So lots of resistors, a bridge rectifier, a discrete bridge rectifier, but a full bridge rectifier, as Electroboom would say. And then literally just stacks of LEDs in series, filling that test tube up. Doodle all these LEDs out and lazily draw just a couple of beams of light coming out them because I can't be arsed drawing all the beams of light. And the resistors I'm going to be using are 22k times 4. See, I could have written 22k 4 times and I didn't. The LEDs I'm going to be using are going to be an unusual type. It's the type that are commonly found in Christmas lights, and they look like this. They are sort of slightly tapered. They've got the anvil inside with the reflector, like this, and the lead coming out. The little chip on top of that, the side electrode with the little wire bond going across, and there's usually another little wire bond at the other side onto the LED. And that lead coming out bottom, and then they have a rather unusual cone recess into it, a sort of concave recess, whereas most LEDs are normally domed or flat. And the result of that is that it makes them very multi-directional. You know, the LED light goes up, hits off that, acts like a sort of little reflector, and it fires the light off in all directions. So no matter what way you view these LEDs, you always get a bit of light. It tends to vary, it's not consistent all the way around, but they are one of the most 360-degree-ish LEDs, which is why they're commonly used in Christmas lights, or fairy lights as we call them in the UK. They've always been called fairy lights. It's not a brand, it's just all Christmas lights are called fairy lights. The test tube is one I originally got for an experiment, probably with the... to make a Fitzroy barometer, Fitzroy weather forecaster. Is that right? It is Fitzroy, isn't it? It's like basically a tube of chemicals that crystals form depending on the ambient temperature and the temperature fluctuations. That will be covered in a project later on. It's an ongoing thing because it takes a while to develop it because literally it requires seasonal cycling. But the test tube is going to be like this. It's going to have lots of LEDs in it going up and then lots of LEDs going down, and I'm going to actually point these LEDs down the way because they're a little bit brighter when viewed from this side. So they're all going to be pointing down the way, although they're going to be going up in a series circuit. And at the bottom I'm going to use the discrete components to build the bridge rectifier, and then it's going to be sat into a lamp holder. And the lamp holder I'm going to be using is the one that's on this slightly butchered LED lamp. So this I've just shaking this out and trying to get the little things out the inside, which have just suddenly lodged solid and decided not to come out. This is a standard British bayonet cap lamp holder. Now, the thing about British bayonet cap lamp holders are not necessarily always British, but bayonet cap lamp holders have the two connections on the bottom. The metal on the side is purely support. In fact, some light fittings, some lamp holders have this earthed or grounded for safety. But the main electrical connection is these 2 points at the bottom. The main advantages of this over Edison screw are that they can't gradually unscrew themselves and work loose. When you put them in, they're quite decisive. The disadvantages are that the spring mechanism at the back used to basically suffer from the heat from traditional tungsten lamps. And what that did was it resulted in a degradation of the plastic, and the little springy pins would stop being springy. I'm looking at this, I'm trying to think, do I have the other, I think that's it there. Okay, good. The connection on these, because it's designed for a little LED lamp, it's normally they put the wire through and then these little rivets push in, and these are the contacts that go in the bottom. So at some point I'm going to be actually taking this off. It's been crimped round, and I've seen this in the Chinese videos where they're actually manufacturing these lamps. They test them in each process of making. And then when they actually put this in, they put the cover on this metal shell onto the plastic, sit it into a unit, and then pull a handle at the side, and it pushes all the pins in that crimps it into the plastic. That's going to, maybe, because that's quite thick plastic, it's going to make it quite hard to get off. I may have to heat this up to get that off. I'll find out when I do it. But then, of course, they put the wires, they put the circuit board in, the wires poke through, they fold them to the side, they put those pins in, and then crop the wires off, and then they usually, this is China for you, they usually have 2 live contacts on the bench that they then hold it across, and the lamp lights, and that shows it works. They just work on the basis that you don't touch the contacts with your fingers. So that's it. That's what we're going to do. Let's do it. And let's start the questions. So the first thing I'm going to do is I'm going to solder the resistors end to end. Now let's make the bridge rectifier first. The bridge rectifier has 4 diodes. I'm using 1N4007 diodes, which are rated about 1000 volts each. I'm going to cross them like this, and I'm going to zoom down a bit so you can see what I'm doing here. I'm going to cross them so the leads are crossing about 1/4 inch, 6 millimeters away from the bodies of the the diodes, and then I'm going to twist. And on this side of the rectifier, I've got the 2 bands pointing towards where I've twisted it, and that's going to be the positive. The other end of the bridge rectifier is going to have the same arrangement. I'm going to cross the leads, but it's going to be the 2 opposite ends to the little bands that are printed on the diodes, and that is going to be the negative. Then I'm going to cross these. Oh, let's turn the soldering iron on. That would be great if I turned the soldering iron on. This is where you hear it humming in the background. The soldering station is a generic Yahoo 8786D with hot air gun. I feel the need to mention that because people will ask. I will get round to answering the questions shortly once I get onto the boring bit of the job. So I'm twisting these leads, and these ones each have a banded end of the diode, a non-banded end of the diode, and these are the AC input to the bridge rectifier. So there we have. It looks just like you draw a bridge rectifier on paper with all the diodes pointing towards the positive. Excellent. The LEDs, let's just pour some LEDs out here. Lovely. What I'm going to be doing is I'm going to be folding one lead up over the side of the LED so I can solder them end to end in a sort of long continuous chain like a string of fairy lights. The resistors, oh, you know what, I forgot. I really forgot an important bit here. In fact, let's go back to the notepad for this. For a start, let's draw a bridge rectifier as an actual bridge rectifier to show you what I mean by that. A bridge rectifier, if that's positive, and that's negative, and that's AC, and that's AC, the diodes all point towards the positive. This is using what they call conventional conventional electrical flow, current flow. The true geeks will say that's not electron flow, but they later discovered that electrons flowed in the opposite direction, but it doesn't matter. All that's important is that the diodes all point towards the positive. That's all that matters. And it means that the current, in conventional current, flows in the direction of the arrow. So when this is positive and this is negative, it will flow through that diode. The positive will go through that diode, and the negative will go through that diode. And then when the polarity changes, negative, positive, the current will then flow through this diode. The positive current will flow through this diode to the positive, and the negative will go to that one. Basically, it's a little gating system that ensures that no matter what polarity are on the AC connections, positive always goes to positive, and negative always goes to negative. It will make sense later on. If it's not making sense now, it will make sense in the future. The resistors I've chosen are effectively a string of 4 resistors in series. One is actually on each leg of the AC supply, but in reality, as long as you've got a resistor anywhere in a circuit, it will limit the current in that circuit. So I've got 4 times 22K. In America, or other countries that use 110 volt, let's note this down, 110 volt to 120 volt use 10K resistors, 220 volt to 240 volt use 22K resistors. Let's extend that down. Let's go 100 volt to 110 to 120 to be inclusive. Japan uses 100 volts. So we've got four 22k resistors. The reason for choosing them, it's not going to be the sort of light that guides you around the house at night. It's not a reading light at all. It's just to provide ambient illumination. It's for visual. You want to be able to look at the LEDs and not be dazzled. And that means the LEDs will also last a very long time because they're not being stressed. So I've chosen the resistors so that if there's a worst case scenario with 240 volts across it, 240 volts or more across those resistors, it's not going to result in a meltdown. If all my LEDs and everything's shorted out, if everything went wrong, it's not going to be a disaster because the current, equals V, which is 240 volts. It's actually going to be less than that, over R, which is the resistance here, which is 4 times 22k is 88k, 88,000 ohms. Let's get the calculator in. I will get to the questions and answers shortly, I promise. So 240 volts divided by 88,000 ohms equals a current of 0.0027 amps. That's 2.7 milliamps, 2.7 thousandths of an amp. That's ample for the LEDs. Slightly less is going to go through the LEDs, but that doesn't really matter. What's important now is if I multiply that, so we've already got that down as 2.7 milliamps. Great as a nightlight, great for a visual effect, but as I say, not a reading light. Power dissipation of those resistors will be P equals I, which is the 2.7 milliamps, times V, which is the 240 volts, the main supply. Keep in mind this is a worst case scenario of all the LEDs shorting out. So, I should have actually left that, but not to worry. 0.0027 times 240 equals. So the power is going to be 0.65 watts, roughly. But that's across 4 of these quarter watt resistors, because that would be too much for a 1 quarter watt resistor. So divide that power by 4 to spread the dissipation across them all. It's going to be 162 milliwatts, and the resistors are rated for continuous operation in a sort of ambient temperature that's sort of normal. Of 250 milliwatt. I like to run them lower. 162 milliwatts is certainly lower, and that's also a worst case scenario if all the LEDs were to short out. In reality, the current will be slightly less through the LEDs. It doesn't really matter. As long as we get more than 1 milliamp, that's fine. 2.7 milliamps is pretty good, actually. Right, now let's get on to the construction. And let's get on to the questions. We've got the bridge rectifier here. Let's solder that and start the questions. When did I start in electronics and how did I end up working with fairgrounds? Right, okay, they're two separate things, but they're kind of connected. When I was young, the electronics revolution happened. Everything was electromechanical up to that point. I'm just going to solder these connections here. And for me, what really typifies this, the electronics revolution for me happened in the 1970s to the 1980s. That's when just things took off. And I was born in 1965. My age is 53 years at the moment. This is part of another question later on. How old am I? I've just answered it. I'm 53 years old. And so if I could ever travel back in time, I would go back to 1975 and I'd get a job in a seaside amusement arcade and I'd just relive that era. It was fantastic because when electronics first really started taking off, and all the old games in the amusement arcades at seaside resorts were electromechanical, fruit machines or slot machines as they're called in other parts of the world. No video games at all. Although having said that, the earliest video games didn't have microprocessors. There were 1 or 2 games. Is it Exidy did Death Race? That's worth looking up on YouTube. After this video, look up Exidy Death Race or Death Race video game. And was it called Death Race? I think it was called Death Race. It got in trouble at the time because it was the first violent video game. And it didn't even have a microprocessor in it, but it did involve driving and knocking down trolls who screamed horribly when you hit them with analog sound circuitry. Yes. But But it's the era that electronics were just starting to creep into games. And initially it was just tiny little bits of electronics. It would be tape loops for sound effects, 8-track tape cassettes. And then it gradually, when it reached 1980, just everything just exploded and the electronics revolution happened. What age would I have been in 1980? I'd have been 15. I was just like, I'd gone from lamps and relays and solenoids. Electronics happened. I just drifted into electronics. That's how the electronics happened. It was a fantastic time. I wish I could go back and live that time again. It's very hard to describe what it's like to be that age and go into amusement arcades, which I loved amusement arcades, and see the revolution happening in terms of electronic game equipment. Texas Instruments with their speech synthesizer chips in the and their early microcontrollers in pinball machines that went from being traditional sort of ching 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 type sort of electromechanical machines to being the ones that say things like, well, the Centaur machine through in that other room there saying, "Challenge me, Centaur," and just or maximum Orbian strength achieved, but really thumping, bassy voices and all these electronic effects. Atari made pinball machines. I think they used 12-volt microprocessors, because in the early days of microprocessors, they didn't realize that lowering the voltage was going to make them easier and faster to make. So they went with standard CMOS technology. I should be building stuff here, shouldn't I? Yeah, great time to be about. The early Atari pinball machines, their sound effects were a bit odd. They sounded like an electric organ, basically. They just makes a musical series of simple tones going when you hit the target. It's very simple, but very good. Very much of an era. Again, YouTube is your friend. If you want to see what that sounded like, it sounds a bit dated now, but at the time it was amazing. Electronic music in that era. My first single was Gary Newman's Our Friends Electric. I remember I was lying in bed, under the covers, listening to my little red plastic radio bought out of RME, Radio Mechanical Electrical. And I'd bought it because I thought it was quite unusual, because it looked like it only took a single AA cell, but it turned out that there were two, but one shoved up the inside and then the other one clicked in. And I bought it thinking it would be interesting to see how they managed to power it from just one cell, but it turned out there were two. But listening at night time to John Peel, who was a DJ who played just basically the latest. He was a real geek. He played the latest music, and Our Friends Electric was one of the first really synthy electronic tracks. And it was just mind-blowing. That was the start of it. Incredible time. Then all the other bands that had preceded that with their music, like Mars, Pump Up the Volume, suddenly all their music was recognised. Did Mars get... Yeah, I'm pretty sure they predated Gary Newman, not sure. The house music revolution. Steve Silk, Jack Your Body. Steve Silk Hurley. That was iconic at the time. Right, okay, so I've just joined the two resistors together, and now I'm going to join them onto the bridge rectifier. So I'm going to crop the leads on both pairs of resistors. Let's zoom back down for this again. Oh, the fairground connection. Okay, I loved fairgrounds. I mean, who doesn't love fairgrounds? I'm going to bend the positive lead up the way to the LEDs and the negative lead up the way, and I'm going to fold the AC leads down the way. And I'm going to do it such that this will probably fit inside this test tube. That's good, that does. So enter Timothy Finlay. Timothy Finlay turns up at primary school. Oh, this then predates the electronic revolution. Okay. But loving the fairground industry, Timmy Finlay turns up at Half Merk Primary School in East Kilbride. And that's where I went to primary school. I was kind of entranced by the fairground. I just couldn't stay away from the fairground when it was there. I'd just hang about on Nat Cadona's waltzer. Was it Nat? Let's see. There was Cecil Cadona and Nathaniel Cadona. Which had the waltzer and which had the dodgem? Not sure. But either way, they were both... what, dodgem? Speedway. Sorry, Speedway is like a waltzer, except you're basically on bikes and they go up and down as they're going round at very high speed and pretty much throw you out the way with centrifugal force. quite exciting. It was one of my favourite rides, the Speedway. Let's solder that. Let's see if I can actually stay in shot, in the middle. So I met Timothy Finlay, and I was helping him pull down his arcade. As time went on, I kept in touch. I was helping him pull down his arcade. He introduced me to John Irvin, who introduced me to Raymond Cardona. Raymond Cardona had a waltzer, the Hellraiser waltzer, which he just loved his lighting. And that's how that happened, because I got involved fixing his lighting controllers. And the rest is history. The Fairground manufacturing company that we set up together, Emanator Automation, we built loads of light controllers and strobes and things. That's how that happened. Next question. Any product that I've declined to show on this channel? Yes, there is. When the USB killer came out, I was asked by a lot of people, could you do a video about the USB killer? And I had to reply to them, I'm sorry, I'm not going to cover that product. Let me snip this plastic off. Let's see if we can remove this in a controlled manner. Lots of noise. The USB killer was originally a sort of novel project. It was done as a joke, or I suppose, or a scientific project by a student. And the idea was it was a device that you plugged into a USB port. I'm suddenly thinking this was a terrible idea. Not to worry. This was a terrible idea. As was the USB killer. It was a device you plugged into a USB port, and it would charge itself from the 5-volt supply, charge up a big bank of capacitors, and then it would step the voltage up and it would dump those capacitors fiercely back into the USB port, and it would damage it. And the whole point of the USB killer was to damage computers. And I think you can probably guess that if someone did that to your computer, it would not be good news. If you turned your back for a moment and someone plugged one of these into your computer and it nuked it and destroyed the computer completely, then that's not going to be a good thing, particularly if you have a lot of software on it. I'm really regretting actually taking this apart this way. I should have done what I was going to do originally and sort of tried to heat up the plastic and then slide this off. I don't know if this is going to work now, but we'll improvise. So yeah, the USB killer, somehow it ended up being manufactured as a product, and yeah, I'm not going to ever cover that product. Whoever actually released that was just a dick. Sorry, there's no nice thing to say about it, because can you imagine someone who's spent their life savings on a course at college, and the school bully has one of these and plugs it into their computer as a joke, fries the computer, and what you're supposed to do, that means you've got to get another computer, because the computers are essential in, your laptop is essential in your course, and it puts people under huge financial pressure. And there's a good chance that the damage it caused, if it went too far into the motherboard, was not something that could easily be repaired. I wonder if the repair shops ended up getting lots of stuff in as a result of that. Stuff that had been damaged by these idiotic products. This does have another pin. Okay, there's another pin. That is the pin I was looking for, not to worry. I'm going to put this in the vise of knowledge and persuade it, because this is where it's all gone horribly wrong. Next question, now that I've covered the fact that I will not ever cover the USB killer. Do I work continuously throughout the year, or just at specific times? Someone also replied, when someone asked that question, someone said the Americans won't be able to get their head around this because of their work ethic and the idea that you don't work all the time for your whole life. So, the quick-potted history of my life, career-wise, apprenticeship at the age of 16, it was traditional in Scotland to go into an apprenticeship straight away from school. If you didn't go into an apprenticeship at the age of 17, you couldn't start an apprenticeship. Thankfully, that's changed. No matter what age you are now, you can train as an electrician, plumber, joiner, welder, whatever you want, you can do it, okay? Things have changed. But back then, it was considered the normal thing was to do that. I'm just going to try this. This is looking pretty good. This is looking very good indeed. Right, okay. I'm going to sleeve these with heat shrink, because I don't want them touching the side of this metal here. So I'm just going to size this. Anyway, I go in at the age of 16 as an apprentice electrician with EJ Steel & Co. Electrical Engineers. What an awesome apprenticeship, really, seriously. It's just the way it turned out. I couldn't have ended up the better company. It was an old school company where the only way into the management was via the tools. So every single manager in that place, male manager, was a time-served electrician. And they knew the industry inside out. They were practical. They knew what they were doing. And they knew what you were doing out in the site. And they knew the trials and tribulations of being an electrician. So I've sleeved this now. I could heat shrink that down. Let's heat shrink it down. It's not going to take that long. Here comes the Yahoo 8786D heat gun. This is the bit I like about this soldering station. This is why I use that buzzy soldering station a lot. I love the heat gun. So the apprenticeship is spent in various places like steelworks. EGI Steel & Co., Stiell, did a lot of work in super heavy industrial environments. For some reason they ended up being specialists in electrical engineering and steelworks doing the power distribution. So a lot of the apprenticeship was spent partly in construction and partly working in steelworks, which was quite frankly backbreaking at times, but just a great experience. I love the steelworks. Right, I'm going to fold these leads. I'm going to get this roughly centered. I'm going to fold it, and then I'm going to put those pins in. So folding leads over, get that roughly centered about there, fold the lead back. Let's zoom down on this. So I do the apprenticeship with EGI Steel & Co. Electrical Engineers, and afterwards I move into the electronics department at the end, and then latterly I leave the company because one of the things about when you do your apprenticeship, it's always good to spend a bit of time with the company you serve the apprenticeship with so that they get their money's worth out of you, so to speak, because they have gone out of their way to give you an apprenticeship. And ultimately, to complete your apprenticeship, you have to move on and try working with other companies just to basically round you off as an electrician. It's just how it works. Some people don't, they just stay with the same company. That's fine too. I'm going to crop these leads, and then I'm going to use unreasonable force to try and ram these pins in without cutting myself on this edge. This is quite hard, actually. Let's push this down without distorting the metal. The pins have gone in. That's pretty good. I shall give them another squeeze later on. I should give them another squeeze now. I'm going to actually just sit my pliers across this so I can press down evenly on all sides. Hopefully this won't slip and then pinch my fingers. That happens. So yeah, EGI Steel & Co. Great, really great apprenticeship. Left very brief spell with Forth Electrical Services, then moved on to Thomas Johnson Shopfitters. Thomas Johnson Shopfitters was a shop fitting company from the Victorian era. It was very old-fashioned, really old-fashioned management who, bizarrely, had this. They treated the workforce like a Victorian company would. I want to point out that Thomas Johnson Shopfitters is now owned by some of the people that used to work for the company. It's completely new management, completely fresh, different, modern company. It's not like it used to be. I feel the need to mention that. I quite enjoyed working with them just because the whole place had a Victorian workshop feel to it. It was an old building, an old industrial, big boxy building with multiple levels and an old vintage elevator that went between them. Really simple, and the electrical division was just one corner of a big room. The rest of the room was filled with benches with joiners at every bench building the cabinets that were used in the shops that we fitted. I'm going to bend here. I'm going to bend all the positive leads up the way initially on about, say, 10 of these LEDs, because I'm going to be joining these LEDs end to end. So I'm going to be bending the positives up in some and then the negatives up in the other to actually, so I suppose ultimately it doesn't really matter. Ultimately, I can, oh no, I want them all pointing down the way, don't I? So yeah, I'm going to have to do that. Great company to work with, Thomas Johnson Shopfitters, but something interesting happened there. It was the Margaret Thatcher era. Margaret Thatcher was possibly one of the most tyrannic prime ministers in UK history. Not everybody will agree with that, but MD who's technical will. She hated technical people. She didn't like workers at all. She thought they were menial shit, pretty much. So to favour her business friends who didn't like the fact they had to pay things like holiday money or pensions or anything like that to these people. She came up with this idea that she'd make going self-employed easy and encourage people to do it. And at the time, a load of joiners turned up, and they were self-employed joiners in the company, and they were getting a higher rate, and it looked, wow, they're getting more money. So I thought, maybe I should try this. And it's a longer story than this, really, but to cut a long story short, I did end up going self-employed, and then was traded off against other co-workers. Whereas the joiners had got a decent rate by default, they decided the electricians should be haggled with, and so I ended up moving on from that. And when I went self-employed, initially I tried setting up my own company, actually an electrical contractor, and discovered at that point that the NIC-EIC, the National Inspection Council for Electrical Installation Contracting, was pretty much a protection racket. MD who's from that era will know exactly what I'm talking about. I thought I was naive. I'm making a real mess of soldering this, but that's okay. It's going to be fine. Basically speaking, the NIC-EIC presents itself as a government body when it's not. It's actually a private company that now describes itself as a voluntary organisation for the inspection of electrical contractors. The main requirement for getting NIC-EIC approval is cash, fundamentally. There's a wee token gesture course that you do, but back then they had a couple of catch-22 situations designed to stop small individuals getting established as contractors. Basically, be NIC-EIC approved. You should never use an electrician if they're not NIC-EIC approved, was their angle. But they had a catch-22 situation. Firstly, you had to have been trading for 2 years before they'd approve you, which meant that if the companies were saying, we need NIC-EIC approval if you're going to be a contractor. And the other one, which was harder to deal with, was they said you had to have a full industrial business premises, because it was really, they were aimed at protecting the interests of large contractors. And MD who sets up self-employed does not immediately go out and buy a full industrial factory unit. It's like there's a lot of money involved in renting or buying something like that. So that was their catch-22 situation, and it meant that I originally intended to start a full electrical contracting company. But it turned out that was going to happen, largely because of the NIC-EIC, who, of course, nowadays they'll just let MD. They'll just approve anybody now, since Part P, which is partly their doing. Let's not go there. But at the time, it left me in an awkward situation. What am I going to do? Because the companies that approached the type of work I was looking for were actually looking for this NIC-EIC approval. So I ended up freelancing, which may actually be the best thing that ever happened, because when you are freelance, when you don't have to worry about all the red tape that goes along with running a company. You don't have to go and get the contracts. The company does that. All you do is provide your services at a slightly enhanced rate, and the advantage to the company that employs you is they don't have to worry about keeping you employed when there's no work. They don't have to worry about holiday pay and stuff like that, because you're just basically dealing with all that yourself. So that's I ended up going freelance, and one of the first companies I got in with when I went freelance was Hussman Refrigeration. I thought Hussman, I really enjoyed working at Hussman Refrigeration. It was like a re-apprenticeship. It was like starting from scratch. It was panel building and installing electrical control systems and troubleshooting electrical control systems for industrial refrigeration. It was fantastic. The hours were very long. That's why I ultimately had to leave in the end, because the hours were a bit too long. That resulted in, that actually answers another question as well. The time I fell asleep into an electrical control panel was with Hussman. I just fell asleep and just slumped into a live electrical control panel, fortunately missing most electrical connections. But another incident, but when I woke up, it was very much a case of extract yourself very carefully. Another time working with them, I fell asleep while working a control panel, and I was lying on the ground next to a refrigeration display case, and I had the electrical control systems drawer pulled out from underneath. And I kind of dozed off, and then half asleep because I was still kind of working, I kind of woke up, semi-woke up, and keep in mind I'm leaning against the earth metal cabinet here, which is a clue what's going to happen. I had my ordinary test lamps that pass a modest amount of current, and I had one lead in my fingers, and just randomly I kind of woke up just enough to poke the other end into a live connection, and I remember the LEDs lighting up on it as the current went through me. Just instantly woke up. Yeah. So where was I there? That was oh yes. So the question was, do I work consistently through the year or just at specific times? I ended up working for a variety of companies. I worked regularly for Hussman. I worked regularly in the end for Northern Light, a Scottish theatre equipment installation company. Initially I started doing the Christmas lights in George Square with them. But latterly I ended up doing theatre equipment installation, which was yet another apprenticeship. That was great. Installing all the trussing and the curtain tracks and curtains and stage equipment and the dimmer racks, all permanent installation with trunking conduit. It was great. Very, very good. Another bunch of very talented guys. That's one thing that I ended up really sticking with Hussman and Northern Light because they appreciated the fact that I kind of knew what I was doing, and I really liked working there because the guys were very talented in their own particular areas. It was well worth working. If you're good enough, you'll just end up working with the same companies all the time. So there were some other companies, Caithness Stage and Lighting I did some work with, and others just randomly that I just helped from time to time. And of course my own business of manufacturing light controllers. Sometimes things clashed. Sometimes you'd be working extremely long hours and trying to manufacture batches of lighting controllers. That was pretty intense. How am I doing here? Have I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That'll do for that string. Now, I want this string going up and then coming back down. But either way, the companies can't be busy all the time. You know, you're only, the reason, if you were full-time employed, you'd be there all the time, but I was freelance. So, say for instance, Hussman had a major contract on there that was pushing their guys to the limit. They would employ me. I'd go out and help, and it means it would free up some of the other guys to do other jobs, or it would let their guys take some time off, which is more important. Now let's see, I want these to face down, but I want the polarity to be different. So the negative's up at the top, I want the positive to be up at the top, and the negative. So now I'm folding the short lead down. Is this going to be long enough? Yes, it's going to be long enough. So let's get another 10 LEDs and fold the short lead down. So I didn't work all the time, and being single with no family, that worked out absolutely fine. Because you earned a slightly higher rate while you're working with them. I mean, overall, I would probably have earned more being full-time on the books, definitely with Hussman, given the hours they worked. But I value my free time. You can't buy free time. Don't go through your whole life just working 7 days a week, 365 days a year, all the time, and then regret it afterwards. Say, you know, I wish I'd spent more time with family, or I wish I'd had more time to myself. It's much easier to do that during your life. It's almost like an early retirement, but you're working. And I don't think I could ever retire. I enjoy work, so I always want to keep working. So part of the time I'd be with Hussman, and part of the time, particularly in the winter seasons when Hussman were quieter anyway, that's when Northern Light picked up the Christmas lighting. So that's when I'd be working with them. So it balanced out. And that just I just enjoyed that life. Partly working with one company, partly working with another, loads of variety, and building my own control systems in the background, and just spend a lot of time at my own workshop just tinkering and doing stuff like this and having a great time. Sometimes I do wonder how I fitted it all in. Wow. Let's solder these together. What's the next question? Yeah, so do I work continuously or year specific times? The answer is at specific times. These days, my income is mixed through a mixture of building control systems and working for companies like PRG doing things. But the next job that I'm on is the Royal Edinburgh Military Tattoo. So it's a mishmash again. Still doing that. It just suits me. What do I think of the British Ring bus? which we'd call a ring final circuit, versus other countries' radio circuits. You know, the theory is, I'm not sure how true this is, that the British ring final circuit, basically speaking, if you can imagine that instead of a radio circuit of sockets in your house, say for instance you've got I'm not sure what the American power circuits are rated at, but you've got a set of pair of cables plus earth coming from your distribution board and going to all your sockets in one continuous line. Here in Britain we don't do that. We have a 32 amp circuit breaker, and we have cables that would not handle that current on their own, but they actually go in a loop. They go from the circuit breaker, they go around all the sockets, and then back to the circuit breaker again, so the current's spread between them. The theory is, and I'm not sure how true this is, that it was to save copper during the war. I'm not so sure about that. It works very well. It means that because you're using a smaller conductor, it's easier to fit the wires into the socket. But the downside is that if the circuit is not continuous, then there's a potential for that wire to be overloaded. Unfortunately, it's also created a complete industry of standards makers who continually invent new ways to test the ring main. Testing it is not easy. It's quite a complex series of tests you do, including some very weird ones that involve, it's an industry. It's very strange. But in that sense, the Australians, they also use 240 volts. I think they use radio circuits. Not sure what current the radio circuits are, but you can wire your sockets in the UK on something like a 16 or 20 amp radio. Not as versatile as a 32 amp ring. But then again, it frees up a circuit breaker position, so you can have twice as many circuits. And ultimately a ring, if you split a ring in the middle, you can turn it into 2 radio circuits anyway, if that makes sense. So it's got its pros and cons, but it's a thing that's commonly used, and a lot of them are miswired. No matter how much they fill in the test sheets, many of them do not have continuity, because when they were doing the building, they completely forgot where some of the sockets were, and it ends up 2 radios fed from one circuit breaker with no continuity. Let's solder this. I should be using flux. What I'm doing here, I'm tinning the leads, both the leads with solder, and then remelting it to flow them together. Oh, next question. How many times have you been electrocuted? I've never been electrocuted, because electrocuted means death by electrocution. Number of electric shocks, quite high, but not full-on electric shocks. When you work as an electrician, when you've been through proper formal training, not the 1 week training that they now do, you can actually become an electrician in the UK in 1 week. From being completely electrically inept, from never having worked with electricity at all, you can attend 1 week training courses and come out at the end fully certified as an electrician. This is not a good thing. Traditionally, the electrical training, when you were an apprentice, you attended college on day release. You do a 4-year apprenticeship traditionally. I think they probably still have 4-year apprenticeships. If you go to a college and the college offers you an apprenticeship, just tell them to go and ram it up their arse, because it's not an apprenticeship. The only apprenticeship that's a real apprenticeship is when you work with a company and you're doing real work every single day. The work you're doing is real, and your experience is real, and you're learning lots, because the person that's with you, working with you, the electrician, is teaching you. That's part of the education. It's a really important part of the education. A seasoned veteran of the industry. Rapidly dwindling number of those. Where was I going with that? Electric shocks. Part of the training that you'd get, part of the thing that happened when you went to college, I went to Motherwell Tech, I had day release. It was a 4-year apprenticeship. 1 day a week would be spent at college being taught by somebody like, for instance, what was his name? What was his name? It's quite a complex. Crawford Cleland. Oh, what a great lecturer. And these were all the lecturers at the college were real electricians. They'd served their apprenticeship, they'd worked in the industry, and they kind of retired into the teaching profession. So one of the lecturers I had was Crawford Cleland. John Stephen was another one. And Eddie Skiles and Joe Farmer. Lots of good lecturers at Motherwell Technical College. But this was back in the 1980s. And part of the thing they did, because they were seasoned experts, one of the things they just kept drumming home all the time, and this doesn't happen in modern training, is how to avoid a current path through your body. The importance, if you're working with electricity, even if a circuit's dead, just get used to being a professional electrician and understanding the route that electricity will take through your body. Well, make sure it doesn't happen through your body. I've just blurbed that soda joint so badly. I'm going to add a bit of flux to this. Flux pen from eBay. Little dab of flux in that, little dab of flux in that, and it'll hiss. It'll make the soda flow better. So they just kept drumming it home, and I can remember Crawford Cleland doing this, and he apologised and said, I know, sorry, I repeat this all the time. Whenever you're working with electricity, just make sure that there's not a current path through your body. And the majority of electrocutions in the UK happen as a result of people who don't understand that simple principle that when you're working something, if this was live in any way, or even it was a circuit that could be live but had been isolated but could potentially be live due to shitty wiring done by new generation electricians, if you're handling it with one hand, make sure the other hand is out the way. Or as I see the local, in Glasgow anyway, the street lighting electricians in Glasgow, they have a glove in one hand but not the other. That gives them the best of both worlds. It gives them the dexterity of handling tiny little screws and the tools with one hand, but prevents the risk of high current flow from hand to hand, because that is quite serious. So the answer to the electric shock question is, I've had lots of tingles and zaps. You'd get that when you're working with electricity, but I've never passed significant current. The most current I passed was actually hand to hand. It was when I was working on an automatic barrier gate. Are these the same length? Oh God, they're not the same length. I'm going to add another LED on. I was working on an automatic barrier gate, and someone else had serviced the control module for it, and they'd botched it. They had left out lots of spacers. Let's turn this around. Actually, have I got the right bit? I've not got the right bit here. I was about to do the wrong thing there. Okay, let's see if we can do the right thing. So they'd left out all the spacers, including the nylon insulator spacers that keep the main circuit board away from the case. Oh, I've got another LED here. Have I just missed an LED? I'm screwing up left, right and centre at the moment. I'm distracted because I'm talking. Very easily distracted though. Working on automatic barrier gate, and they'd left out the insulators, the spacers that keep the circuit board away from a metal case, but they'd also left out a metal spacer that earths the metal case. This was bad news for me. I pulled the control module out of the barrier gate, which, can you imagine just lifting a metal PC case or something like that? Oh, this is the wrong way up. I really am screwing everything up right now. Hold on, at least I caught it before I put it in. It would still light, but that LED would be duff by the time I'd finished powering it. And what happened was the whole case of that metal case anyway came live at 240 volts. And I was holding a metal barrier with my left hand. I felt the current go right across the chest. Quite dramatic. In front of lots of other people, which makes it worse. That's the last thing I want. Remember, it's really important when you get an electric shock to look around to make sure nobody saw you get it. This is looking relatively good. This is looking very good. So what I'm going to do now, I've got the one polarity going up one string of the LEDs, and then I'm going to bridge it across, and then the polarity is reversed, so it's coming down the other strings, so they're all in series. Hold on, where is the tube? Let's see if we can actually squeeze some more LEDs in this and answer more questions, because there's a whole load of questions to ask that were asked. I'm going to add 2 more LEDs to each string. There we go. That's going to give me plenty more time. So negative is cut short. Let's make sure we get the right polarity now. So that's positive is coming up from the bottom. Yeah, okay. So the lead that's folded down is the positive, and the one that's going up is the negative. Right, yes, this is a... Right. Positive folded down, Negative up. This is where I will screw it up. I'm just going to double check. There's no harm in double checking. You know what they say in this, the joinery industry mainly, measure twice, cut once. Because if you double check it, you're less likely to make a mistake. So, where was I? Yeah, the electric shocks, when you get an electric shock, if you work with electricity, you will, because generally speaking, because you're technical, you're going to be the one who's in there fixing something that's faulty. It's faulty. That's why you're there. It's the electricity is going somewhere it shouldn't, and you might find it travelling through you. So just make sure you don't provide that current path through your body. I'll make a video about electrical safety at some point, about what happens when you get electrocuted. But the good news is that very few people actually die from electrocution. Well, everybody dies from electrocution, but very few people die from electric shocks. It's all a wee bit blown out of proportion. But it can be quite traumatic. It can be a bit of a life-changing experience, which is more important. Right, okay, so I want to extend this one now. So I've got one LED with the, okay, let's, so I've got the negative is folded down here. And the negative is folded down on this one, so the positive's up. Okay, that's perfect. Next question. Have I tried making a wind-powered garden light? I did. But I found that a wind power, certainly, even though it's quite stormy here a lot, it alternates between stormy and nothing. There's not, if you go outside, well, if you were to go outside now, it might be windy where you are now, but you might find it's completely calm, and it takes a good amount of power, of wind power, before a wind turbine will start going. We have a lot of wind turbines in Scotland, actually, power generation wind turbines. But then Scotland does generally have a lot of wind in the areas they're situated. Next question. What did you want to be when you grew up? I wanted to be a lift engineer, an elevator mechanic. That's because I loved lifts. I loved riding them as a kid. And also, let's move back into shot here. My dad took me into where he worked, which was the Mitchell Library in Glasgow. He sort of just took me in and gave me a tour around the place. I was very young, and one of the things he wanted to do was take me up on the roof, but it turned out the roof door was locked. But next to, on the route out to the roof door, was an elevator controller, and it was really old-fashioned. It was the big slate panels in the walls that really went bang and flashed when they switched, and it was terrifying. I was really scared. I didn't even want to go past it. And, you know, scary things like that actually make you want to do it, if you know what I mean. It's like things that sort of scare you when you're a kid kind of latch in your mind and become kind of important. So I wanted to become a lift engineer. My dad stopped me. He said I had to become an electrician first before becoming a lift engineer. And back then it turned out that that was not quite right, because the class I was in at college had lift engineers in it. They were in the same electrical class, becoming electricians, because a lot of lift engineering is electrical. Good mechanical aspect as well. A lot of mechanics choose to become lift engineers just because they usually get asked to help out and then end up liking it as a job. So it's a mixture of mechanical, electrical and electronic. It might suit some of you, particularly if you like mechanical, electrical and electronic stuff. Is this going to fit? Yes, it's going to fit. This is looking pretty good so far. Let's put that on there. Going to have to adjust the lead length a wee bit. Might have to just angle that one down, which is not a bad thing because they were a bit close together at the end, to get the leads around about the same length. That is looking pretty good. I'm still fascinated by lifts. I think they're great, but I'm glad I didn't become a lift engineer, because these days 90% of it is like error codes and buttons, and you know, it's usually that it's not got the charm that the old electromechanical controllers had. This is good news for many lift engineers or elevator mechanics, but bad news from the sense of the fun of trying to find faults in old electromechanical systems. How old are you and what operating system do you use is the next question. I am 53 years old. The operating system I normally use for engineering tasks is Windows. Windows, what is it? Windows 8 I'm using at the moment. But when I'm browsing the internet, I use a Chromebook because it's faster. Because it's really lean and efficient and also more secure in many aspects. Not totally secure, but every operating system has its weakness. Next question. You're very in step with new technology for someone of your age group. Is it easy to keep up? Right, okay, now, see if you go into any of the design labs in, keep in mind I'm 53, if you go into any of the design labs in like Texas Instruments or Hewlett Packard, if they're, I'm not sure what state they're in these days, or any of the places that's designed the semiconductor equipment, you'll find that a lot of the people working there are in their 50s. The team leaders are often sort of like, they're the ones that are kind of, because they're the experienced ones, they're running the groups that are doing the tasks, design work. So 53 is pretty much dominant in electronics. We kind of grew up during the electronic era. We're veterans of the electronic industry. So it's very easy to keep up with it because it's just a continuation of the industry we started in. Another thing about people of my age, the 50s, you know that really good music video, I'm just talking about a generic music video here, the one with really thumping bass, and basically speaking it's the guys singing and then they're surrounded by lots of young ladies who basically just jump up and down and jiggle their tits up and down in time to the music, and everybody's like, oh, great video. The people behind those videos are also in their 50s because they're veterans of the music industry. They know what ticks the boxes. You'll find this out as you get older. When you think, you're getting to the age that you'd have thought in the past that you'd have been past it, you're actually becoming an expert in your area of industry. This is almost done. I think we should try this out and see if it lights, or it might not light. Let's make sure we get the polarity right. Double checking, no harm in double checking. Next question. How do you handle trolls? Well, welcome to the internet. I've been on the internet since dial-up era, so I'm no stranger to it. Let's make sure let's plug this in and see what happens. The LEDs are all lighting. Shall we just take a closer look at that? Let's take the exposure lock off and turn the light off and take a look at this. That looks pretty nice. It's actually, the camera is doing it a favour here, but it's still pretty damn bright. That is looking very nice indeed. You'll see a very slight ripple because although the combined forward voltage of the LEDs, there's no smoothing. Although the combined forward voltage of the LEDs is relatively lowish, it's still, there's this portion at the bottom of the sine wave they're not lit. The colour, it looks ferocious yellow on the screen. It's a golden warm white here. That's what I'm seeing. Which is better. When I pull it away from the bench, you can see the colour it actually is projecting on the bench. That's very nice, actually. Now we just have to work out how to actually glue this into this. And that was tricky last time, but I've got a plan this time. I'm just going to pause momentarily just to adjust the lighting. The lighting is adjusted. I don't think I need the soldering iron anymore. Famous last words. So I'll turn that off and I shall gingerly remove this lamp from the holder. Now, last time I tried filling this up with the resin and it didn't work because when I tried pushing the test tube down into the resin, it created a sort of pressure in the tube that kept pushing it back out again. I've got a plan this time though. This may not work. I'm not sure. I've got a little bit of foam sized to the bottom of the tube that I'm going to wrap round it and then I'm going to try wedge it in. This may not work. It's kind of working. And then I'm going to push that down. This may not work. This is experimental, by the way. So getting back to that question, internet trolls. I've been on the internet since the dial-up era. I've seen the evolution of it. I'm used to internet trolls. They happen. It doesn't matter what you do. I often say that if I put up a video that showed me rescuing puppies and kittens in a bag from a river, people would still hate the video. There'd always be trolls. It doesn't matter what you do. If you've got a YouTube channel and you're being excessively trolled, just learn to get over it. It's just, it's something that happens. There are miserable people. If someone is really being malicious and leaving malicious comments, you go and look at their channel and it invariably says, this user has no content. Pretty much sums it up. So do I want to actually go a wee bit... Actually, I do want to go a bit thinner with this. Let's cut a bit of this off. I'm making this up as I go along here, as you may notice. Yeah, trolls don't bother me. I'm seasoned. I'm a veteran of the internet. I know what happens. Don't let them get to you. Don't let them bully you. It just doesn't matter. Let's stick this on. In fact, that might work. As I say, I'm just making this up as I go along. Let's pull it a bit tighter. Oh, I'm going to regret pulling this tighter. Oh, I am already regretting pulling it tighter. Okay. And now we'll have to trim a bit off. Okay, let's trim a bit off. And a bit more tape. It's all going Blue Peter right now. Blue Peter was a British TV programme for kids. It was very good. Is it one of the best Blue Peter episodes that I can think of? Do John Noakes, Noakes, I think it is, Trafalgar Column in London, and he used to go on these little adventures, and one of them was going up to clean Trafalgar Column. And honestly, health and safety did not exist back then. Even when I saw it the first time around when I was a kid watching the programme, it was scary back then watching it. And now I look at it now and think, oh no, even I quite like working at height, but particularly the ladder that comes out, if this is the column, the top actually stood out from the main column. So you'd go up a ladder and then the ladder would kick out the way to go up onto that. So you were hang upside down with no safety harness, just such a distance above the ground. It was just terrifying. But that makes great TV. So what I'm going to do now is I'm going to get a laser. Yes, a laser. I have my laser. It's a violet laser. And I've got ultraviolet curing glue. This is called Maximum Impatience. This is me, right? Okay, see? I've only just, out of all the questions, this was supposed to be a long video. I don't know how, it's probably stopped and started again at some point. This video was supposed to be long enough that I could answer all the questions, but I've only answered half a sheet of questions here. I've got another full sheet to answer. So that it may be multi-videos. I'm going to have to invent other things to make. Let's try and make sure this looks relatively straightish. Once it goes into the holder, it probably won't be straightish. Yeah, it looks pretty good. And what I'm going to do is I'm going to use this ultraviolet curing resin from eBay. Everything's off eBay. And I'm going to drizzle it in to that closed cell foam area. I'm going to put a couple of bits around it. I don't know if I'll fill the whole thing up with it. And then I'm going to fire the laser into it to cure the resin almost instantaneously, because it's very good for curing, ultraviolet curing resin very fast. Laser. So that's curing that. Next question. If I could have a dinner party, what guests would I invite from the past or present? Oh, I have a horrible feeling that resin has just sunk right down through that. It slid down the side of that foam. Maybe that cell wasn't as closed foam as I thought it was. I may have to improvise again. I can't think of how many guests I'd actually invite. I'm not really a dinner party type person, but I wouldn't mind. The video has just, there'll be a glitch there because the video has just stopped and started again, which means it's probably about 30-minute mark. I'd invite Tesla, and then I'd show him an Android tablet or something like that, just because that would just completely defeat all the rules of time. I'd want to show him what had happened with electricity and bring him up to date. I'm not sure if that would go. That would be a bit of a... that would really screw up with time, wouldn't it? That would be a disaster for time. If I went back and did that. Show him the future. Yes, this may not be working as well as I wanted it to work. I've also put a big smear of resin up the side of the glass now, but I don't think it really matters. It's not going to be terribly visible. How's this going so far? It's Pretty solid. That's pretty good. So what I might do now that I've done that, rather than try and do it all with this resin, I may actually pour in some standard, the two-part resin that you mix together. I might as well, because then I can answer more questions. And also, this video has rolled past one of the thresholds and it's started again, so I kind of know roughly where I'm at. This has kind of all happened quite quickly, I think, in relative terms, this building a lamp from scratch. So, right, let's clean up this mess and continue on. Two-part resin, Poundland two-part resin, which I'm going to mix together, and I'm going to fill this up just to finish that job of sealing the end up, just to make sure it's kind of well and truly fixed. So let's squirt all the leftover stuff that's in here, this two-part resin. Next question. How do you beard so well? Right, I want to say, when I was young, I latched onto the image of having a moustache because I saw tradesmen with moustaches. I wanted to be a tradesman when I grew up. Initially, I wasn't sure which type of tradesman, but from a very young age, I latched onto the image of being a worker. This might actually be a built-in thing. I've got a theory that some humans are actually designated in the same way that you get beehives with different bees with different functions. I think that some humans are designated as workers and engineers. So one of the things that a lot of the tradesmen at that time had, they had moustaches. It was just going through that era, and that became important. But tragically, I just couldn't grow one. For a long time, literally in my late 30s, I couldn't grow a moustache. I could grow the beard to a degree, sort of bum fluff in the chin. But from the about late 30s onwards, suddenly it just took off. That's the point everything started growing. So if you can't grow a beard, don't worry about it. And also keep in mind that the beards just look different at different ages. So as you get older, it will change its appearance, its style. I kind of like the way it's gone grey. It's kind of awesome. I like, if I could choose the way it had gone grey, I would have chosen this way. It looks quite good. It's got the stripes in it. Let's actually lift that out of there and try and drizzle this resin in. I've just drizzled it all down the side of the lamp holder. That's not a great result. So let's try and drizzle this resin in here. And then I'll put it in that holder. I really have made a mess now. Not to worry, I shall wipe this and then just surreptitiously wipe it under my bench where it can cure in its own good time. There we are. It's not electrically conductive, this bit anyway, so it's not going to affect its conductivity or connection. So obviously with that Edison screw, if you're in a country that uses the Edison screw lamp holders, you're going to have to adapt and connect one of those leads up to the metal shell and onto the back terminal. But this is just, I'm using the B22, the bayonet cap holder, because that's just what our local sockets are. That's what most of the sockets, lamp holders in the house are. The beard, yep. Remember, if you try growing a beard, if you want a beard, that it goes through a really itchy stage, and you're not going to get instant results. Don't give up. It will go through a very itchy stage when it gets to about 6 millimeters. It will tend to stick in the pillow. Sounds terrible, but after it's gone past that stage, it stops being itchy and it starts being just fine. So that's pretty good. That's looking. It's all filled round, so I'm going to leave this standing up in the vise of knowledge here till that cures. Let's answer more questions while I tidy up here and remove all the resin that I've now smeared all over my bench. Excellent. And residual resin. Do I need to stick anything? This is the wrong time to think. This is the point that you end up with some resin left over and you think, oh, can I stick anything else with it? And by the time you've found something to stick, it's kicked, it's gone off, it's started gelling. So yeah, the beards. And what about beard maintenance? I don't really do much beard maintenance. I'll do a Tank Abbott. A Tank Abbott is one of my sort of like icons for heavy set fighting type guys. I've always liked the Tank Abbott look. That is largely what the beard is aimed at. It's styled on Tank Abbott when he was going through that stage with the beard coming down then quite flat at the bottom. That's what I do. I pull the beard sort of straight and then just take a pair of scissors and chop the bottom off flat just for appearance. Yeah, we all have our icons, are the figures we look up to. He may just have been quite a sort of oafish, but adorably oafish big fighter, but just flaying fists everywhere when he went in. I quite like that. Recommended tools. If you're getting into electronics, get yourself some basic screwdrivers, a pair of cheap snips off eBay like this, side cutters. Just look for the cheapest. The Chinese use them en masse in the factories. Meter-wise, if you're starting electronics, all you need is a basic meter like this. This will do resistance and voltage fine. Not super accurate, but good enough. Don't be ashamed to start off the meter like this. And the solder iron, you want to get a decent solder from a local supplier. Lead-based solder. But the solder iron is basically anything you can get that works. You know, you can start electronics very cheaply and easily. As you progress, you'll get a feel. You'll decide that certain tools you want something better, better screwdrivers, better soldering iron, and it just evolves. And you know, as you appreciate the tools, you'll know what you're looking for, and that's just how it always works. Have there been cheap Chinese electronics that impressed me? Yes, there have. The cheapest stuff is just some of the shortcuts they take, some of the tricks they use to actually achieve a lot from a small number of components is just amazing. Whereas you'd normally expect a sort of electronic module and then a module and then a module all to build together, sometimes they use one component that does three different things. And that's like an electronic puzzle. When you reverse engineer it, you have to not just understand the circuitry, you have to understand what's actually happening in use. And some of the designs are really clever. They're very good. So some of the cheap electronics is amazing. Favourite IC and microcontroller. Favourite integrated circuits. In the young days, it was 555, 4017, LM3909, which was an LED flasher, which is obsolete now, unfortunately. Microcontrollers. My favourite microcontrollers are the PIC microcontrollers, and the reason for that is I was an early starter with the microcontrollers. I dabbled with the Z80 processor, moved on. I learned to program on a Heathkit programming system, but then I'm pretty sure it's the back of a Fernell catalogue that they advertised the PIC microcontrollers with a development system that was actually affordable. It used to be up to that point. If you wanted to program microcontroller, you had to get the manufacturer's dedicated programming system, and it cost thousands of pounds. Like, we're talking about £10,000 for a development suite for some processors. And suddenly, this program was available, and it only did a few of the PIC microcontrollers, the one-time programmable type, and then the EEPROM-based one. But it only programmed about 4 microcontrollers, this unit, but it was affordable. It was only a few £100 compared to what the other equipment was. So I got into the microcontrollers then and started using them in my products. And once you're used to one type of microcontroller, you tend to stick with it. So I'm a fan of the PIC microcontrollers. So this is gelled. It's almost there. No, it's not. How did Big Clive come to be, the name? Well, initially I went on, I decided to get after I'd gone on the internet, through Demon Internet, I decided to get a website. And I fancied getting on with Clive.com, but Clive.com, as had Ralph.com, they'd both been cyber squatted by a company that just took over all the names and just squatted the names. And if you went to Clive.com back then, it said, do you want to buy this name at a stupendously high price? They were just basically cashing on the new cyber industry of the internet and domain names. So everybody calls me Big Clive anyway, because I'm very tall and broad-shouldered. So I looked for Big Clive, it was available, I registered the domain, the website took off, and now this channel's taken off from that. So that's how Big Clive came to be. And in the case of Ralph, we talked, what domain do you want? And Ralph wasn't available, so I thought, well, Ralphie, spelt this particular way. I think Ariel PHY had already been taken as well, but Ralphie, Ariel FY hadn't, so that's how Ralphie ended up being Ralphie. Next question, do I personally update my website or do I get a geek to do the HTML? Nope, I've been programming my own website since the dawn of the internet, since dial-up era. That's why it's so fast, ultimately. It's a very simple website, it's very old-fashioned, it's written in very lean code. The images are only 320 by 240, they're tiny by modern standards, but back when I did it, it was the dial-up era. File sizes had to be really small, so most of those images were taken with a floppy disk based camera, with a spinning magnetic disc in it. And it was a Mavica. Who made the Mavica? was it Sony Mavica? Sony made the Mavica. But it produced 320 by 240 images with heavy compression, but good quality compression. And back then, the video monitors and the screens on laptops were low resolution, so that image filled up the page quite significantly. Now, of course, with the super high resolution screens, the images look tiny, and I'm afraid that's all you get. That's the images. By all means, zoom in them to see them in more detail. There's a lot of detail in them, but they are tiny images. That's how it is. And I resisted the temptation to update the website because ultimately, YouTube is now, the bigclive.com channel on YouTube is now the replacement for the website. It's the evolution of the website. But the website's there, it's been kept there because in some parts of the world they have slow internet, very slow internet, and it was designed to deal with that. If you go with your phone to bigclive.com and load any page on that site, it will just instantly load like that because they are designed for fast download even over the worst internet connections. Right, you know what? I think I'm running out of time here now of things to do. So, well, not time. There's plenty of questions. That is still a bit tacky. More questions. What do I think of emulated Scottish accents? Well, if you think of Fat Bastard Eating Wee Babies from the Austin Powers film, the Scots have we find our ridiculous Scottish accents, the really exaggerated ones. Och, aye, the new, we find that quite funny. We've got a good sense of humour. So even things like one of my favourite cartoon characters is Groundskeeper Willie from The Simpsons, and it doesn't matter. You can't make a bad joke in the sense that the Scottish have such a wide-ranging sense of humour that even when Willie the groundskeeper says, "Aye, we're all perverts," we find that funny. So I quite like this sort of fakish Scottish accents. They're kind of amusing more than anything else. My own American accent just tends to be generic American. It's not really from any particular part of America. Now some of you will say that is from a part of America. But it's just got that slight twang to it that is generic American. How are babies made? I don't like to get involved in real babies because they're very messy and they're loud and they scream a lot. Yeah, jelly babies are a different matter though. Jelly babies are a mixture of gelatin and water and sugar, flavouring, colour mixed together, and then they're poured into, and this is where it gets interesting. You get a cornflour mould, a cornstarch mould, which is basically loose corn starch, and it's laid into trays, and then a mould is pressed into it to form the imprint of what you want, and it holds that shape perfectly. The jelly is then squirted in as it passes underneath into those and then settles in, and then it goes into a setting sort of chamber where the gel gradually sets. Once it's set, the easiest way to get out the mould, all you do is tip the mould upside down through a grid. All the flour just instantly collapses, and you're left with the clean jelly babies. It's you can see that happening for like jelly beans and stuff like that on YouTube. It's clever how they do it. Because the powder is then collected again, the cornstarch, and then it's reused. It's filtered and they reused. So it's a mould that is just cycled from scratch, and it's very easy to get things out of because literally it just crumbles away from them, leaving the slight powder coating. That's quite fascinating. What do I struggle most with being alone? Nothing whatsoever. It's almost like I was designed by Mother Nature to be alone. I don't have a problem with that. Right, okay, I think that's enough. The lamp is finished. The resin has most likely cured. It is cool now. It's still a bit sticky on top, but that's not a great issue. Let's plug it in again and make sure it still works. And that is how you make exposure control off, light off. That's how you make an LED lamp with a simple resistive dropper, super low power, but this would work great as a nightlight. And it's looks smart. It looks nice. This is the angle it's designed to be viewed from. This is swamping out completely. Let's try it. I'm going to bring the lighting back. Just give us a second here. I thought I'd shield you from that coming back. When you view it from this angle, it's going to be in a ceiling light. When you view it from the angle, because it's pointing up the way, that it's sort of chandelier style, it's a lot brighter viewed from down below, which is where it's designed to be viewed from. But that is quite good. I like that. It's a good result. So yes. And that concludes this video. I didn't answer every question, but I can answer them in another video. So that's that. Ah yes, that looks good. A worthy addition to my usual motley collection of weird customised LED lamps. I think just about every decorative lamp in this house is custom made. Note that the chain had to be shortened when I moved in here because the person that lived here before was quite short, and this spiky bit was at forehead height when I moved in. Some of the light fittings were at face height. It was a bit extreme. But now the question is, let's take the exposure off here and get it up. Will we win? We won.